Hi friends, in today's video we will learn how to find unique solution of system of first order differential equation using fundamental matrix. So for that, let's take an example. Let's take a differential equation something of this form: dx by dt is equals to a times x, where a is a matrix. Now let me take an initial value of x. Let's say the initial value of x is omega at 0. So whenever t is 0, my value of x will be omega. So taking this into consideration, what I need to do is I need to find unique solution for this x. So as we all know, in order to find solution for this differential equation, what we basically do is we will try to get rid of derivatives, right? So in order to do that, what we will be doing is we will be sending this x with this dx. So what we have is dx upon x is equals to a times dt. So I just swapped the position of x and dt. Going ahead, to get rid of this derivative, what I will be doing is I will be simply taking integration on both sides. So by that I have integration of 1 upon x as log x, and a being a constant matrix, I will take this out. So what will be there with me is just 1. Integration of 1, as you all know, it will be t with respect to t, and since we are done with the integration, we will put a constant of integration, that is c. Going ahead, so I just don't want this log in my sum. So in order to get rid of this log, what I will be doing is I will be changing this entire equation in exponential form. So to do that, what we basically do is we have exponential e at the base. So as we all know, what we will be doing is we will be putting this thing as the power of e, and we will be sending this x over here. So what will happen is we will have e raised to at plus c, and in the right hand side we will have x. So obviously we have the solution of x with us. X will be something of this form. So just to write it in more proper form, what we can do is, and also with that we need to recall, like we have initial value of x, we need to make use of this to get rid of this constant c. So let's try to use that, and let's try to move further. So what I will be doing is I will be splitting this into two parts. As we know, we have addition in the power. I can always split this into two parts, one with this and one with this, and that's equals to x. Now let me try to make use of the initial value which I have. So recording what is my initial value given to me. So I know that whenever t is 0, my value of x is omega. So using that over here, I can say when t is 0, I have my x value as omega. So let me try to use these values in this equation and see what's the value that we are getting. So when I put a 0 over here, it will become e raised to 0, that is nothing else but 1. So let me write it over here like e raised to 0. This will remain e raised to c, and this will be omega now, because whenever t is 0, my x is omega. So I know this is 1, so I can remove this directly. So what I have is basically I have e raised to c is nothing else but omega. So what I can do, I can just replace this value of omega over here in this equation, and I have my final equation of x with me. So therefore I can say x is nothing else but e raised to at with the value of e raised to c, that is omega. So that is my final value of x which I have with me. Now there comes a question like how to find value of this particular thing, right? That is the exponential form. So we have a direct formula which we can remember basically. So for e raised to at, we can expand this simply in this form, something like this: I plus t times a plus t square upon 2 factorial a square plus t cube upon 3 factorial a cube, and this process will go on. So now the main trick over here is we will manipulate this matrix A which we have with us, right? We have a matrix A with us. We will manipulate this matrix A in such a form that whenever I take second or third power of this A, automatically all the numbers in that matrix should transform to 0. So that we will be seeing in an example which we take up later. So in that example we will see how to transform this matrix into such a form that after doing 2 or 3 powers, that will become 0, and by that what we mean is this entire process will stop after a particular power. So we will have the remaining thing there with us. So obviously this the remaining thing after doing addition of the remaining parts which we have in this equation, that will obviously be a matrix, and that matrix is nothing else but the fundamental matrix which we are considering while doing the solution. Now so that's all we had with this particular initial value problem. Now taking an example where if this is not 0, right? So sometimes what happens is in examination we get like initial value of x is omega but not at 0, it will be at 1. So how to treat such type of sum? So it's again very simple, it's not that difficult. So let's see how to tackle this. So again, the entire process till here will remain the same, because after this step we are putting the initial value of t, right? So let me write this directly over here. After solving all that integration part and exponential form, I have something of this form with me. Now in the initial value I will use this 1 and see like what is the final value of e raised to c that I am receiving. So when I put this t as 1, so it will become e raised to t a times 1, e raised to c is equals to, when I put 1 over here, automatically this will get transformed to omega, because whenever t is 1, my x is becoming omega. That's what this initial value is saying. So I have e raised to a times e raised to c is equals to omega. Now in order to find e raised to c, what I will do is I will send this e raised to a over there beside omega. It will become e raised to minus a over here when it comes beside omega. So let me put this value of e raised to c directly over here, right? So what we will have is, therefore, so when I put this e raised to c value over here, I will have e raised to at times omega with e raised to minus a is equals to x. So I can simply write this as, therefore I have value of x ready with me. Value of x is nothing else but, let me write this omega at the end, and let me write this e raised to at and e raised to minus a together. So what we observe over here is, like using a simple rule of indices, I can simply club them together as something like this: e raised to at minus a times omega. Again I have the privilege to take this a out, so let me take that a out. So what will I have with me is e raised to a times t minus 1 times omega. That will be the unique value of x with me whenever the initial value is given to me, whenever the initial value is at 1. So just summarizing the entire concept which we learned right now. So whenever the initial value is given at 0, so initial value of x is omega at 0, at that time we will be having such a value of x with us, where expansion of this term will be in this form. And coming to a scenario where the initial value is given to me at 1 instead of 0, at that time we will be dealing with x in such a form. So I think you have got the concept, and yeah, using this entire concept we will be solving a couple of examples in our next video. Thank you all for watching the video. Have a great day.